Okay, so in this section, we're going to start to evaluate trig functions at different angles. They're not special right triangles, okay? So what we're going to do is we're going to take a point on the coordinate plane. They're just going to give you the point. And then they're going to say, find the trig ratios for sine, cosine, and tangent at that point. Okay? And what you're going to do is they're going to give you a point, any xy coordinate, it can be in any quadrant, and you're going to find that point. You're going to draw a line from that point to the origin. That is your hypotenuse. You're going to draw a line from that point to the origin. Then you're going to draw another line, and you're going to drop it down to the x-axis. So it doesn't matter where that point is. If that point is over here, that's your hypotenuse, and you're going to draw a line directly to the x-axis. That's going to create your right triangle that you're going to be able to use to find those values. The x and y values are the length of the legs of those right triangles. The x and y value of the coordinate that they give you, that is the length, the value of the two legs. So if this was the point 5, 7, what's this? What's this? 5. And what's this? 7. That is your x and y values. That is the length of the legs. Now, your hypotenuse, if I have this on a circle, the hypotenuse is also the same thing as the radius of the circle. Do y'all see that? The hypotenuse is the radius of the circle. The radius can never be negative. The radius of a circle can't ever be negative. Does that make sense? Okay. So what we're doing now is we're starting to transition from plain old right triangles to putting the right triangle on the coordinate plane so that we can begin to introduce you to the unit circle, which is after this. The unit circle is a special circle that has a radius of 1. Okay? But these have a radius other than 1. You don't know what that is, you have to go figure it out. In order for me to find sine, cosine, and tangent, I need the length of that hypotenuse, which is the same thing as the radius, right? So, how would I find the length of the hypotenuse? Pythagorean theorem. You're going to use Pythagorean theorem, okay? And so use Pythagorean theorem to find that missing value, and then all you're doing is writing the ratio. There's not really anything solving, you're just finding the ratio of that. So is the sine, 5 over 3 or square root of 2 over 7, okay? So that's what we're doing in the next couple of problems. You need to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, okay? So let's look at an example. Sometimes they give you the drawing, and sometimes they just tell you the point, and you have to go do the drawing yourself, okay? These problems, they give us the drawing. They want us to find sine, cosine, and tangent of theta. Theta is that angle here. In this problem over here, theta is still that angle there. That's my reference angle. Because the example on the right, it's showing you the big angle, but you can't draw a right triangle with that large angle, so you use the reference angle, which we talked a little bit about yesterday. So in this first example, here's our point. Our point is the square root of 15, negative 7. That is the coordinate. I'm not sure if everyone can see that. That's the square root of 15, comma, negative 7. Okay? That's this point here. So what we're going to do is we're going to create our right triangle. They already drew the hypotenuse for you. When you create the right triangle, you draw directly from that point to the x-axis. You're never going to connect anything to the y-axis. You're always going to connect it to the x-axis. Okay? And so I'm going to take this, And I'm going to drop that down, and there's my right angle. There's my right triangle. The line you connect to the x-axis is where your right angle is. Now, you need to write in the values of the legs. My x value is the square root of 15. So that means this is the square root of 15. That's my x value. My y value is negative 7. So that means this is negative 7. So this is the square root of 15. This is negative 7. We have to go figure out what that is in order for us to find sine, cosine, and tangent. You need all three of those values, right? So for all of these problems, you're going to be missing the hypotenuse, which is the same thing as the radius. You're going to be missing that. So you have to use Pythagorean theorem to go find it. So we have, let me move this up a little bit. So we have square root of 15, negative 7, we need this. So you say negative 7 squared plus square root of 15 squared equals c squared. Or you can put r squared, or you can put h squared, however you want to represent that. And so negative 7 squared is 49. Square root of 15 squared is what? 15 equals c squared. So 49 plus 15 equals c squared. Take the square root of both sides. C equals 8. Now, if it ends up being something that you can't simplify, you want to leave it in simplest radical form. You don't want to calculate it and round off anything. You want exact values for this. All right? So, C is 8, so that means this is 8. So now I can go find sine, cosine, and tangent. So sine is opposite over hypotenuse, which is, in reference to, this is theta. That's my angle. Your angle that you're talking about is always at the origin. Okay? In reference to this, opposite is what? Negative 7. And hypotenuse is 8. Cosine is adjacent over hypotenuse. What's adjacent? Square root of 15, and hypotenuse is 8. Is it okay to leave it square root of 15 over 8? Yes, it's okay. It's on top. It's fine. It's only a problem when it's where? At the bottom. Put it at the denominator. Tangent is opposite over adjacent. Opposite is negative 7. Adjacent is square root of 15. Is that good? No, what do we do? Multiply the bottom by the square root of 15. But if I do that on bottom, I also have to do it at the top. So that equals negative 7 square roots of 15 over 15. So these are my three answers: sine, cosine, and tangent. Okay, this is x is 4. So that is the length of x on the x-axis. X goes left and right, correct? So, like, if I were going to map my way to that point, starting right here, I'm trying to get to 4, 3. This is 4 over and 3 up. You understand? Okay. So when we do Pythagorean theorem, we say 3 squared plus 4 squared equals c squared. And so you end up with 25 equals c squared, so c is equal to 5. Now, when we do opposite, adjacent, and hypotenuse, That is what is opposite theta. What is adjacent to theta? What is the hypotenuse? Hypotenuse is the same. But sine of theta is opposite over hypotenuse. So opposite theta is across from it. That's 3. And hypotenuse is 5. So 3/5. Cosine theta is adjacent over hypotenuse. So adjacent to theta is 4 over 5. And tangent theta is opposite over adjacent. So that's 3 over 4. All right, so it says find sine, cosine, and tangent giving the following point on the terminal side. So yesterday we were graphing those, and we talked about initial side and terminal side. Terminal side is the angle, okay? So you're going to graph that, you're going to plot that point. Now, you don't need to count out literally 12 spaces and 15 spaces. It just needs to be an estimate, because all you're going to do is draw a rough sketch of that right triangle. So, -12, -15, what quadrant is that in? Third, right? So this is what I do. This is what I do, okay? You may not want to do it this way, but this is what I do. Because it's kind of killing 2 birds with 1 stone, so to speak. So start at the origin. -12, where do I go? So -12, and then down -15. So that's how I draw it. I map it like a road map, and then it's putting my values in place as I do it. This is the point -12, -15, but you don't need to label that point. These is what really needs to be labeled, right? Theta is always at the origin. Okay, so we need to find C. The square root of 369 can be broken down into the square root of 9 times 41. 9 times 41 is 369. If you take 369 and start dividing it by perfect squares, that's how you can figure that out. Divided by 4, then divided by 9, then divided by 16. And so that's 3 square roots of 41. That's what C is. Sine of theta is opposite over hypotenuse. Opposite is -15. Hypotenuse is 3 square roots of 41. Before I get rid of that square root, I need to ask myself, can I simplify this? Yes, I can. 15 and 3 can both be divided by 3. Correct?
Yes.
So this becomes -5. So now this is -5 over the square root of 41. Now I can fix it. Multiply the top and bottom by the square root of 41. And that equals -5 square roots of 41 over 41. At that point, you still want to check to see if it can be simplified anymore. Now it can't. 5 and 41 cannot be reduced, but you do want to make sure and check that, because sometimes it can. Okay? So this is sine. Cosine of theta is adjacent over hypotenuse, which is -12 over 3 square roots of 41. We're going to do the same process again. I'm going to simplify -12 over 3, and that's -4. So that's -4 over the square root of 41. Now I'm going to fix it. I'm going to rationalize it. So that's -4 square roots of 41 over 41. And again, that cannot be simplified anymore. Now, tangent is opposite over adjacent. That one's easier. Opposite is negative 15. Adjacent is negative 12. So it's negative 15 over negative 12. My negatives cancel. And I reduce 15 over 12 by dividing them both by 3. So 15 divided by 3 is 5. And 12 divided by 3 is 4. So again, let's make sure you have your triangle drawn correctly. So if I'm mapping this out, where do I go? To the right, how many? And then down 8. Theta is always at the origin. Did y'all get the hypotenuse? It's 17. So if you do negative 8 squared plus 15 squared equals c squared, you end up with c equals 17. So that makes it easy, right? Okay, so sine of theta is opposite over hypotenuse, which is, what's the opposite? And hypotenuse is cosine of theta is adjacent over hypotenuse, which is what over what? 15 over 17. Tangent theta is opposite over adjacent, which is negative 8 over 15. Okay, this is continuing on what we're doing right now, except that they give you a little bit different information. What you need to understand is where the angle measures are on the axis in degrees and in radians. Okay? In degrees is 0, 90, 180, 270. You need to understand that the first quadrant is between 0 degrees and 90 degrees. The second quadrant is between 90 and 180. The third quadrant is between 180 and 270. And the fourth quadrant is between 270 and 360. Now, those are easy to see in degrees. But you're not used to seeing this x and y axis in radians. Okay? Because every problem, it's going to give you one trig value. So this one says that sine is 3 over 5. We know that sine is opposite over hypotenuse, correct? Oh. Sine is opposite over hypotenuse. So if sine is opposite over hypotenuse, then the opposite is 3 and the hypotenuse is 5. But you need more information than that for you to be able to figure out where that triangle is. So they give you that information. That information tells you which quadrant that lies in. That's important because you need to know what quadrant to draw that triangle in. So in radians, it goes 0, pi over 2, pi, and 3 pi over 2, and then back to 2 pi. Those are the same measurements in degrees. Pi over 2 is the same thing as 90 degrees. Pi is the same thing as 180. 3 pi over 2 is the same thing as 270. And 2 pi is the same thing as 360. So when it gives you the direction, when it's telling you what quadrant it's in radians, you need to know where that is. Okay? And if you just have a mental block and you can't remember what quadrant is between pi and pi over 2, change them to degrees and then figure it out. Okay? You have the ability to change radians to degrees. Okay? So if you forget, change it to degrees and then figure out what quadrant it's in. So they give us two pieces of information. They give us one trig value and then they tell us what quadrant it's in. Once you have that information, draw that triangle, write in the values that they give you. They're giving you 2 out of the 3 sides. Okay? You need to remember that the hypotenuse is the same thing as the radius, and it's always what? Positive. The hypotenuse is always positive, because in these problems, the hypotenuse is the radius, and that can't be negative. And so, this tells me sine is 3/5, that's opposite over hypotenuse. And what quadrant is this? This is saying theta is between pi over 2 and pi. What quadrant is that? That's the second quadrant. That's this quadrant here. That's between pi over 2 and pi. Okay? So, you're going to do what we just did. You're going to draw a little makeshift axis, x and y axis, and then you're going to draw a right triangle in the second quadrant. So we're going to draw a right triangle in the second quadrant. Now we're going to fill in the values for opposite and hypotenuse. Remember, the hypotenuse is always positive. And the reason why I'm saying that is because when you have a problem that says the sine is negative 3/5, the negative either has to belong to the top or the bottom. And if it's, you have to look at them, if one of those is a hypotenuse, it cannot be negative. Okay? And so, opposite, so remember, your theta is always at the origin. So this tells you where to draw that right triangle, what quadrant you draw it in. So, opposite is 3, so here's theta, so this is 3, and hypotenuse is 5, so that's 5. Use Pythagorean theorem to find the missing piece. This time, you're going to have to take the square root of both sides. You have to consider plus or minus. When you take the square root, see, before, the problems before, we were finding the hypotenuse. So when you took the square root of both sides, you didn't consider plus or minus, correct? But if you're finding one of the legs, well, they can be negative, depending on what quadrant it's in. So let's go find this missing piece right here. So we'll say x squared, because that's what we're missing. We're missing the x value. X squared plus 3 squared equals 5 squared. So x squared plus 9 equals 25. And we'll subtract 9 from both sides. So x squared equals 16. Now when we take the square root of both sides, x equals plus or minus 4. Either positive or negative 4. What does it have to be? It has to be negative 4 because this is negative. Because we're in this quadrant. Do you see why it matters? It matters. This information right here matters a lot. You can't do this problem without knowing what quadrant that's in. Okay? So x equals negative 4. Now you can go answer sine, cosine, and tangent. Now for these problems, they give you one, you just have to find the other two. Okay? So they gave us sine. Sine of theta is 3/5. That was given. Cosine is adjacent over hypotenuse, right? What's adjacent to theta? Negative what? 4. And hypotenuse is? Okay. And tangent is opposite over adjacent. What's opposite theta? 3. And what's adjacent? Okay. So they generally won't put negative in the denominator. They'll either put it out in front. They usually just put it out in front. But it's not wrong if you just leave it 3 over negative 4. Okay? So between pi and 3 pi over 2, that's the third quadrant. One, 2, 3, that's down here. So when you draw that right triangle, it's going to look like that. Theta is always at the origin. Sine is what over what? Opposite over hypotenuse. So opposite and hypotenuse. One of those has to be negative. Which one? The opposite, because the hypotenuse can't be negative. The hypotenuse is the same thing as the radius. So you cannot make the two negative, because that's the length of the hypotenuse. So opposite is -1. So what value are we missing, x or y? X. We're missing the x value. So you have to go find that. Anybody get it? What's x? It's not a gas phone. Negative square root of 3. Okay? So let's do this. We have x squared plus -1 squared equals 2 squared. So x squared plus 1 equals 4. Subtract 1 from both sides, so x squared equals 3. When you take the square root, that's plus or minus the square root of 3. But since it's here, it has to be negative. So x equals negative square root of 3. All right, so sine theta they gave us. That was given. Cosine theta is adjacent over hypotenuse. What's adjacent? Negative square root of 3. And hypotenuse is 2. And tangent is what over what? Yeah. Good. Opposite over adjacent. And opposite is -1. And adjacent is negative square root of 3. What happens? The negatives do what? They cancel each other, correct? So those are gone. And so we have to fix this. We have to multiply the top and bottom by, good. So that's equal to the square root of 3 over 3. Okay, first we're going to practice finding a reference angle. Once we do that, we have to find the exact value of this using the reference angle. So that's the reason why we're finding the reference angle. Okay, so first, we have to find the reference angle, okay? These are just examples of what reference angles look like, all right? So if this whole thing is 120, if this is 120 degrees, what's this? 60 degrees, right? If they want us to find sine, cosine, or tangent of 120 degrees, that is going to be the same thing as sine, cosine, tangent of 60 degrees. Okay? Now, 60 degrees, we could do a little special right triangle and figure that out, right? Because that's one of those special angles, right? So these problems, if they want you to find the exact value of something that's bigger than 30 degrees, 45 degrees, or 60 degrees, then you have to be able to find a reference angle and use a special right triangle to solve it. Okay? So these are just examples. So if it came all the way down here, okay, if that angle was 210 degrees, what's my reference angle? 30. How'd you find that? Subtracted 180 because it went 180 and then another 30. So we could do a right triangle with a 30 degree angle. That's still 30, 60, 90. Okay? Same thing over here. So you just have to figure out, and if they give it to you in radians, change it to degrees so you can figure out what you're doing, so you can find your way around. Okay? And so, if I want to find the reference angle, I want theta prime. Theta prime is what they use to name the reference angle. Okay? So 320 degrees is theta. How do I find theta prime? I want to know the reference angle that belongs to 320. Well, if you graphed it, this is what? This is 180, 270, right? If I went all the way, it'd be 360, right? That's too far. So remember when we were graphing them, it's somewhere right here, okay? That is 320. I want to know what that angle is. So what do? Subtract. 360 minus 320 gives you 40 degrees. So theta is 320. The reference angle, theta prime, is 40 degrees. Okay? Negative 5 pi over 6. I have no idea where that is. Change it to degrees so we can figure out where that is. Okay? Change it to degrees so we can figure out where that is. How do we change it to degrees? We multiply it by what? 180 over pi. What happens to my pi's? They cancel. Okay? So, negative 5 times 180 and divide by 6. Negative 150. Okay, well that I can figure out where that is. Okay, so if I had to graph that, negative means I start here, but then where do I go? I go down instead of up, because it's negative. So this is negative what? 90. And all the way to here is negative 180, right? I don't need to go that far. I need to come somewhere right here. My reference angle is the rest of the way to the x-axis. Okay? So theta is there. What's this? That's 30 degrees. Your reference angle is always positive. Okay? It's just a distance measurement, an angle measurement from that angle to the x-axis. Okay? So that's 30 degrees. And so my reference angle, you need to change 30 degrees back to radians so that it matches the original theta. So how do we change 30 degrees back to radians? 30 pi over 180. So that is pi over 6. The reason why we're doing this is because the next problem, it wants us to find tangent of negative 210. And they want exact values. So if they want exact values, it's got to be one of those 30, 60, 90, or 45, 45, 90. So you have to figure out what that reference angle is so that you can do that. Okay? So this says evaluate tangent of negative 210. Well, you can go ahead and calculate that, but it's going to give you a decimal answer. It's not going to be exact. So tangent of negative 210, first, figure out what's the reference angle that goes with negative 210. So, start at 0. Do I go up or down? Down. Down. So this is 90, negative 90, negative 180. If I go all the way here, it's negative what? So I can't go that far, right? So this is negative 210. So you see where I am? I'm in that second quadrant, right? So what you're going to do is you're going to take this and drop it down, but you need to know what that is. That's your reference angle. So how do I figure out the distance, this angle here? So if all the way here is 210, back it up. So from here to here was 180. So 210 minus 180 gives me the rest of the piece. And that's what? 30. Can't see it, but that's 30. 30 degrees. Everybody see that? Now, I can find tangent of 30 degrees. That's a special right triangle. What are the ratios for 30, 60, 90? 1, 2, square root of 3. Correct? 1, 2, square root of 3. But because it's in the second quadrant, those signs, you need to make sure they're correct. So opposite the 30 is always the 1. Is this positive 1 or negative 1? Positive. That's above, that's y value, that's positive. Okay? 2 goes where? Hypotenuse. Can the hypotenuse ever be negative?
No.
No. Square root of 3 goes right here. It's negative because that's negative x. So if I'm going to redraw this out here just so it's a little bit bigger and better. So this was 30. This was 1, 2, square root of 3. So if I want tangent is what over what? Opposite over adjacent. Good. So opposite is, that was negative square root of 3. Opposite is 1 over negative square root of 3. So we have to fix it. Multiply the top and bottom by square root of 3. So that's so you have to find your reference angle so that you have to first graph that angle, which is why we learned how to do that yesterday. Then find that reference angle. That reference angle in these problems will always be one of those special angles, 30, 45, or 60. Okay? You know the ratios, 1, 2, square root of 3, and 1, 1, square root of 2. Place those and put your signs appropriately depending on where that angle is, depending on what quadrant it's in. Okay? I want y'all to try this one. Cosine negative 4 pi over 3. Adjacent over hypotenuse. What's adjacent? Negative 1. And hypotenuse is 2. Here's your homework.